Good morning, everybody, and welcome to another episode in the Aquarium's Online Academy. My name is Emily, and I'm going to be with you this morning, and I'm joined by my friend James, who's behind the computer here. So he's going to change everything that we see behind us. And my friend Allie is at our questions computer today. So if you have questions, feel free to text us and let us know. The phone number for the questions is right here, so you can text to 562-286-1838. And then if you're watching us on demand, like on YouTube, after we've gone live, you can actually email us, and we're really good at getting back to those emails. So you can email us at live, L-I-V-E, at lbaop.org. Great. So welcome, everybody. As I mentioned, we are broadcasting live from Long Beach, California. And it just so happens that the scene that you see behind me is something that's pretty familiar to us here in Southern California. And today, we're going to be talking about places in the ocean like this and other places where animals make their home. Let's think for a moment. Is there a word that we as scientists use for a place where animals make their home? Have you heard a word that might mean a place where living things make their home? Yeah, if you know this word, go ahead and shout it out to everybody that's around you, or shout it out just to be shouting this morning. Did you say the word habitat? Great. Well, that is the word that we as scientists use to describe a place where living things make their home. So this happens to be, right in back of me, a habitat located here off of Southern California. I think of this, and I always describe it this way, as our ocean backyard. Of course, you may not see your backyard, this backyard, every single day, but this is actually what it would look like if we were to just swim a little ways offshore and dunk our heads way down and actually dive down deep. And so this is our ocean backyard. This is our local ocean neighborhood. So take a look here for just a moment in the kelp forest, and let's look at what we notice. So scientists, what do you notice about this scene right here? Are there things that are living in this view? And are there things that are non-living in this view? Interesting. There's actually a lot of activity going on in this view right now, isn't there? Let's talk about those non-living things first. So when we think about non-living things, I mean things that aren't plants or aren't animals or aren't things that are like plants and animals. I mean things like rocks and water and things like that. So take a look right here. What are some of the non-living parts of this habitat? Go ahead and shout it out. Maybe Mrs. Lopez's class, maybe you can shout it out or talk to one another, turn to your neighbor and talk to one another, or type in on your Zoom if you are actually not in person. Tell each other maybe something that you notice that's non-living on this scene. Maybe you noticed there are big old rocks here. Do you think that we have rocks in our ocean backyard here in Southern California? We absolutely do. We have a lot of these big rocks here, and so that's why we put these rocks inside of this kelp forest habitat here at the aquarium. This habitat happens to be called Blue Cavern. Are there non-living things? Yeah, there's definitely water. There's lots of water here, right? How about down here? James, actually, if you can take away the question hotline number real quick. What do you notice down here? What's the bottom like? Do you think the bottom of the ocean is the same everywhere? Have you seen it different in some places? Yeah. So it turns out here in Southern California, we have a combination of sandy bottom like this and rocks. And sort of depends. Sometimes there's big rocks, sometimes there's little rocks. Still in other places, in other habitats, there might be really different ocean floor there. You might have completely rock bottom, and it might even be a different kind of rock. For example, if there are volcanoes nearby, you can have basalt rock on the bottom. It's dark, dark rock. But here in Southern California, we don't really have volcanoes around, so our geology, our rocks are actually different. So this is part of the non-living parts of this habitat. All right, well, what else do you notice maybe that's living now inside of this habitat? Oh, Isabella, good observation, by the way. You noticed the rocks too. I noticed them too. Great observation. Now let's take a look at what are some of the living things you notice in this window. Okay, so we're looking at some of the living things in this window. Ooh, you see any interesting fish like this one right here? That's a barracuda, right? That is a big, big fish. Oh, and there's a bunch of fish moving around back there. Yeah, there's a bunch of fish that live here. And in fact, Halldale had a great question. Why are only some of the fish brightly colored? I wonder that too. Maybe we'll talk a little bit more about that. Great question, great wondering question. For right now, let's stick to the I notices and then we'll dive into the I wonders, okay? So I notice. What else do you notice about this scene? We notice there's a bunch of fish. Oh, whoa! Did you see all those fish out there? What is it called when there's a bunch of fish together? Is it a school of fish? Yeah, you're right. A school of fish lives inside of Blue Cavern here. Yeah. There's also some fish that are not close together, but there's a couple of them. Ooh, do you see the big one in the back there? What do you notice swimming back there? Did you say it? You can say it out loud. It's a shark. Yeah, we actually have sharks that live inside of this habitat. Now, there's one more thing that I notice that doesn't really move a whole lot, but is a living thing, or supposed to be modeled after a living thing in this habitat. And it's actually the thing that sort of makes this habitat really special. Did you notice it too? I'll give you a hint. It's sort of greenish brown in color. Oh, I know. You all saw it. There's seaweed behind me, isn't there? Yeah, this is the thing that makes this habitat so special. This is called kelp. So maybe, James, can you show us a video clip maybe of some kelp? Whoa, we've been transported to a kelp forest habitat. Now, this is the thing that's really, really special about Southern California and our ocean backyard. We have kelp here. Now, why would this be a good place to live? I wonder, why would this be a good place to live? If you were a fish, would you want to live here? Maybe, maybe not. Let's think about that for a second. Yeah, maybe this is a great place to hide, right? Definitely. There's a lot of algae, a lot of kelp where maybe animals can hide. Do you think that if there's lots of animals living here too, would it be a good place to hunt? Yeah, it might be a really good place to hunt. So we were wondering why this might be a good place to live. There's lots of places to hide and to hunt, and maybe that just brings a lot of different animals here. So it actually turns out it's a really diverse habitat. So there's lots of different things that live here. Take a look at one of our other exhibits here at the Aquarium of the Pacific. This is another kelp forest habitat. What do you notice here? Yeah, it's a slightly different view, but there's a shark right there. You can see, though, we have a bunch of different fish living here. And so there's all different places for them to sort of tuck into, especially if you look at like the fish that kind of stay close to the kelp and they don't move a whole lot and they sort of drift with it, right? Did you notice that? Take a look. Yeah, this kelp provides a great place, a great habitat, and it adds what we call, as scientists, we call it structure. So it's not just bare, sandy bottom here. There's lots of kelp here. Now, kelp is really interesting because it turns out it doesn't grow everywhere. It only grows in certain number of places here. And we're one of the places here in Southern California. It has to be not too hot, and it has to have the right amount of nutrients here. And our water is really nutrient rich here. That's why sometimes it looks kind of like brownish green. The water looks brownish green because it actually has a lot of nutrients. And so that's really, really good for things like kelp. So let me show you some artificial kelp. Now, in Blue Cavern, we happen to have artificial kelp. I'm holding a strand of artificial kelp right here. This is very similar to what we have in Blue Cavern. And so we actually do put artificial kelp in Blue Cavern. That's mostly because we don't want the fish to nibble away all the kelp. If you ever have a chance to go visit our friends in person at the California Science Center, they put live kelp in their exhibits. So, but this is what a kelp looks like. Whoa! I think that was a senorita that just swam by. That's a big fish. That's actually not that big a fish. It's about 1.5 hands of mine. But anyway, this is kelp right here. Let's take a look at kelp and see what we notice. Now remember, kelp is the main part of the habitat here in Southern California. It's very special. It only lives in a couple of places. And this is the bottom of the kelp. Does it look like anything you've seen before? Does it kind of remind you of anything? Yeah, it kind of looks like almost like a suction cup to me, or almost root-like in structure. So this is called the holdfast. And if you look at our kelp here, our kelp all stick to rocks with their holdfast. And then, of course, these stand straight up. And then we have what looks like leaves. These are called blades. And each blade has a balloon next to it. And that helps keep it floating. So these little balloons are called pneumatocysts. And they're actually, they're like little balloons that stand up and help keep the kelp upright so it can reach up. Because where do you think kelp gets their energy from? It gets its energy from the sun. It actually acts a lot like a plant, and so it photosynthesizes. So it wants to reach right up. So it has these little balloons that help it to stand up. In the right conditions, kelp like this can grow and grow and grow. It can grow feet per day if it's really perfect conditions. And so lots of animals can live here. And that actually begs the question. I think earlier Halldale had asked, why are only some of the fish brightly colored? Well, if you want to hide in a place like this, is it helpful to be colored like this? It definitely is. Let's take a look again at a kelp forest habitat with fish in it, and we can see the colors of the fish are sort of make it so that they can sort of blend in with the rocks and the sort of the grayness of the water, and of course the brownness of the kelp there. And so they blend in really well. There's a couple of them that aren't that good at blending in right there. I wonder why that is. I wonder why that is. Oh, Isabella wanted to know, can fish eat seaweed? There are some fish that do, and that's actually why, as I mentioned, that's why we put artificial kelp in this exhibit, just so that it doesn't get nibbled up, and then we aren't constantly replacing it as well. Victoria wants to know, why are rocks important to the animals? Well, as I mentioned, great question, by the way, the kelp holdfast has to stick to rocks. It doesn't stick to sand very well. So the rocks are the place where the kelp can anchor, and then the animals can find their home in the kelp. The other thing is, you do notice there are some fish, occasionally you'll see some fish like tucked away and living down at the bottom. If you tune in at any time, maybe there, it doesn't look like there's any right now, but if you tune in at any other given time, sometimes you can see a couple of fish hanging out down here on the bottom. So the rocks can be kind of important, even just as a place to sort of tuck away. Great. So we do have a bunch of fish that are sort of brown, green, gray colored. A lot of them are sort of neutral colored. There's a couple of fish that stand out here. I wonder why those fish are so bright. Can you think of any reasons why, if you lived in a place that was brown and green and gray, why it might be important or special to be orange? Let's take a look at that fish that's really bright orange. That is a really sort of famous fish here. This is the Garibaldi. So this is a close-up look. Now, Garibaldi is not actually this big. We're zoomed in. If you saw them on the view earlier, they're about the size of like maybe 2 of my hands together. And so they can be a small, medium-sized fish, but they're really brightly colored. They're really brightly colored. It turns out because they're territorial, and they want to make sure they're seen so that they can say like, hey, look at me. This is my area. And they're really, really territorial. And in fact, if you were to go snorkeling or swimming in a kelp forest habitat, sometimes Garibaldis will even swim right up to people just to keep you out of their area. So they like to be brightly colored because they're territorial. They want to be seen. Halldale also wanted to know, do sharks eat the fish? That's a great question. So in a habitat like amber forest or blue cavern, it's not actually that common for those kinds of interactions to happen. And that's just because generally in the aquarium world, we take a sort of proactive, approach to their diet. So when you feed the sharks, the sharks are actually fed. These sharks happen to be fed by hand, but when you feed the sharks enough, it sort of minimizes other interactions like that. So they actually sort of keep to themselves because they are fed a good amount every single day, enough to like keep them from getting annoyed with their tank mates. So that's actually something that we do here at the aquarium. Leilani wants to know, how does an animal decide if it is a good place to live? That's actually a great question. Animals aren't really great at actively deciding, but it turns out that they are, it sort of happens over time. The fish that find the best spots and have tendencies to stay in certain areas, those are the fish that survive. And so just over time, their habits, their behaviors evolve so that they may spend more time hiding in the kelp, or they may spend more time tucked away near the rocks. But different animals have just really individual behaviors. And every time they do those types of things, it's always a cost or benefit. So it just depends. Great question, Leilani. And then Zoe wanted to know, so many questions today. Zoe wanted to know, why are some fish alone and then some are together? That's a great question. So in this view right here, we're looking at highlights. So you can see at the very bottom, James rewound it a little bit. This is typically what we would see closer to like the very early morning or nighttime for us. And we see, oh, here comes that eel. You can see it right here. Here it comes. It's right here over me. You can see some of the fish stay together, some are not. Some of them stay together in like a loose association. Sometimes we'll call that a shoal instead of a school. And that's just their individual behavior. So some species find safety in numbers and some are rather solitary. And so it's just the way that their behaviors are as fish. And sometimes they'll be solitary and they'll get together occasionally from time to time as well. So it just depends on the type, which is sort of an answer that we give a lot as scientists, but it really is very specific. Take a look here. What do you notice about this view now? We rewound it so that we're looking at nighttime or sort of early morning maybe, because I can actually see a little bit of light. Kind of different view, right? Did you notice these fish? Yeah, these are different fish than what we were looking at earlier. So it turns out if we watch this view over time, different things come out and sort of have different behaviors at different times of the day, which I think is something really interesting. You could study a habitat all day long and notice different things. So I encourage you to actually check out our webcams. Just whenever you get a free moment, you can see who's active, who's up and about, and what are they doing. And that way you can notice what they're doing and maybe wonder new questions. So here we have, oh, the giant sea bass is tucked away now, kind of ambling into the rocks there. So they do all sorts of different things at different times of day. All right, so it looks like we got most of those questions answered. If you do have other questions, feel free to text us. And then I do want to take us maybe to a different aquarium habitat and maybe a different place in the world that it's modeled after. So, ooh, what have we here? Now, this habitat looks a little bit different. So I'm going to step off to the side here. Why don't you take a moment. What do you notice about this view now? It's really different than our ocean backyard here in Southern California. It looks different at least. Has anybody seen anything like this before? What is this habitat called? You can shout it out if you know. I'll pretend like I can hear you. If you said coral reef, you're absolutely right. This is a coral reef habitat. Now, this is not my ocean backyard. I wish this was my ocean backyard, but this is not at all my ocean backyard. The water here is much, much warmer. And because the water here in the scene behind me is much warmer, different things live there. Also, the nutrients are really different here. So whereas in Southern California, where we have lots of nutrients, here in the water, there's very little nutrients. Most of the nutrients are actually found inside the coral. So take a look here. What else do you notice about this habitat? I noticed that there's actually lots of different types of corals. Now, I don't actually know all the names of the corals. I know only a handful of the names of corals, but look at the textures and shapes. Can you see how many textures and shapes do you see? Almost all of those are just individual different kinds of corals. Now, what is a coral? Do you think coral is an animal or a plant? Huh. It's kind of an interesting answer, actually. It turns out corals are animals, but they have a plant-like creature living in them. Now, it's not actually a plant, it's an algae, but that's actually what they have living in them. Let's take a closer look. I'm going to take you over to the side camera here, and I'm going to show you some coral skeletons. Now, if you think about you, right, like inside of you, you have bones, and then you have like muscles, and then we've got skin on the top. You might have nails. We have all sorts of stuff that covers our bones, right? It turns out that corals have sort of a skeleton structure too, but instead of bones that make up like a hand, like mine, they have bones that look like this. And it's not true bones. It's actually just more like a skeleton structure. So take a look at that. Here's one coral. Here's another type of coral right here. What do you notice about these two corals? Now, just as a reminder, these are about the size of my hand. These are just small samples of corals. Some of them do get much, much bigger than this. But take a look right here. What do you notice about these two corals? Do you think that they're the same kind of coral or two different kinds of coral? Take a look. Yeah, I think that they might be two different kinds of corals. This one right here looks kind of nubbly, right? And this one right here, the other one looks kind of like mini little antlers, right? Like lots and lots of little antlers, really pointy. And it turns out, yeah, these are two different types of corals. Let's zoom way in and take a look here. Now, I know it looks really just bumpy. If you look carefully, you can actually see that there's little circles. So like this thing right here that looks like a little circle, it almost looks like a little flower. That's where one animal would live. And so each of these little circle areas is like a little pit where one animal lives. And it turns out corals are colonial animals, which means that there's many creatures that share one sort of skeleton structure or one bony skeleton structure. So lots and lots of animals live together here. And same thing here, except that the skeleton looks really, really different on this one. And so each one of those little holes is where one coral lives, and they all live together. Because of this, they actually are fairly slow growing. And then they grow and grow and grow. And just like the kelp provides a lot of habitat, the corals provide a lot of habitat. I like to think of them as a living landscape. So maybe, James, we can pop back over to look at a coral habitat here. So this happens to be a lot of actually artificial coral that we put here at the aquarium. It still provides structure, a place for the animals to hide or just like swim in and out of, but they don't eat it here. But you can see this is a very active habitat and really different from the coral reef. From the kelp forest habitat we looked at earlier. What do you notice about this scene that's different than the kelp forest habitat? The coral reef is quite different, isn't it? So take a few moments to look. Yeah, there's certainly a lot more activity. And instead of kelp, we have, of course, lots and lots of different types of corals. Now, as I mentioned, these are artificial corals. We do have some live coral here at the aquarium. And we did get a question. One of our learners today, this is a live coral exhibit, wants to know, what do we feed the coral? So that's a great question. As I mentioned, they are animals, but they also have plant-like algae living inside of them. So one of the things we always do is we make sure we put bright lights over top them. And it's actually really important to have the right amount of light every day. So we want to make sure that there's like light and dark, just like out in the ocean, they would have light and dark as well. So we want to make sure we have the right light dark, the right wavelength of light coming through. And then, yeah, and then there's other corals that we have that we can also actually actively feed, and we'll feed them tiny little planktonic creatures. And that's because the individual animals that live on corals, they can get part of their food from the algae that lives inside of them, or they can actually actively feed. Soft corals are especially the ones that actively feed. So they look more like anemones. Let me show you an anemone here. I have a model of an anemone. So you can imagine in a coral, if we were to zoom in on one of those little holes that we saw in the skeleton, it would look kind of like this. So except with way fewer tentacles. Coral tentacles usually have 6 or 8, depending on their stony or if they're hard corals or if they're soft corals. But it looks just like this. It's actually a relative, like a very distant cousin of an anemone. Here's a great view of them all sort of plugged in here. And so they'll come out, they'll feed actively, and then they can retract back in if they need to. But the thing that's cool about corals is that they eat both ways. They're able to harvest energy from the algae that's inside of them, and some of them also actively feed out in the ocean as well. So they actually have tentacles that come out and they feed. And there's so many of them that live out there, and they provide all kinds of habitat for lots and lots of different animals. Now, Damien wants to know, why are corals different colors? That's a great question. It turns out the algae that they have inside of them helps to dictate the color that they are. So some of them are brilliant, like oranges, pinks, things like that. That all has to do with the tissue, what's living in their tissue and what color their actual tissue is. And when I mean tissue, I mean like it's not quite like muscles, but it's sort of like the living stuff that's outside of their skeleton. So all of that depends on the algae and also just the pigment that they have. What else do you notice about this habitat? It's very busy, isn't it? Yeah, there's lots and lots of animals that make their home on the coral reef, especially these fish. It's a good place to live because, well, let's think about it. Why might this be a good place to live? What did we talk about with the kelp forest? Yeah, there's a lot of places to live here. And it turns out there's a lot of animals that come here. So it's actually also a good place to hunt. And it turns out coral reefs are really important nursery grounds as well. And so they're actually a really good place for creatures to come, babies. And so these are really, really active neighborhoods, really active habitats inside of the ocean. What do you notice about their colors, though? A little bit different than the other habitat, wasn't it? Why might this habitat, I wonder, actually, why might this habitat be more brightly colored? Huh. Well, the kelp forest habitat was kind of grayish, greenish brown. But this habitat's got like pinks and yellows. And it's actually really hard to see all the true color just from the lighting that we have over top. Actually, if you change the lights also, the colors look a little bit different, which is really neat. Well, do you think? Yeah, I actually think because the habitat is so colorful, the fish are also very, very colorful, and that helps them to blend in. Great thinking, scientists. All right, it looks like we have time for maybe 1 or 2 more questions as we wrap up. I hope you enjoyed exploring these different neighborhoods, these different places where creatures live in the ocean. So far today we've looked at the kelp forest, which is our ocean backyard, and we've looked at the tropical coral reef right here. Oh, this is another exhibit of a tropical coral reef. These are soft corals, so they look a little different then, right? Yeah, I noticed that too. So this one, instead of having like the like knobs and the antler parts, this one is actually looking like a fan. It looks like a big fan that can wave. All right, so hello to Mrs. Nicolosi's class. I appreciate you viewing. As we wrap up, someone wanted to know, what is coral bleaching? Well, that is a great question. So as we know from earlier, corals have this skeleton inside of them, and then they have living parts on the outside. The living part on the outside has algae that gives them their color, and they actually have to take care of the algae that lives inside of them by providing sunlight and everything. When conditions become really tough for this coral, the first thing that this coral is going to do is get rid of the algae. When it gets rid of the algae, it turns white like this because it loses its color. Now, you might think, what are some reasons why this coral might have a tough time? Well, it turns out corals like to live in a very narrow band of temperatures. That means that they don't like it too hot, they don't like it too cold. They like it just right. And it turns out as you burn fossil fuels like coal, oil, or natural gas, it forms a heat-trapping blanket around our Earth, and it means that heat can't get out. It's like a blanket that you can't kick off. As the atmosphere heats up, it also heats up the ocean, and sometimes that pushes the corals just outside of just right into a temperature that they're not good at. So it turns out things that we do here in our everyday lives can actually help corals that are really, really far away. Remember, I said that as we burn fossil fuels like coal, oil, and natural gas, that actually impacts these corals. So using less coal, oil, and natural gas actually goes a long way to helping distant habitats like coral reefs. It actually also helps kelp forest habitats because kelp don't like it too warm either. So if you have any other questions, feel free to email us. I want to thank you for joining us. My name is Emily, and for those teachers that are out there, if you can go ahead and take a moment right now to text in the number of students that you have watching, viewing with you, we would really love to get that information. We're trying to keep better track of how many students we're serving, the types of populations, and who's out there watching, and we would love that. So if you can send us the numbers of students that are viewing with you today, we'd appreciate it. Everybody have a wonderful day. We'll see you soon.